To complete our project, no further circuit changes are required. The circuit remains as it was from our last lesson. Alright, so now we're going to upload the code for our Joystick LED matrix game. Let's go ahead and do that. Wait for that to complete. Here it goes. Okay, so here we go. So as you can see, there's a falling ball, and if you don't catch the ball until it reaches all the way to the bottom, you'll see lose, that lose message. So I'm going to move that. I'm sort of moving a platform that's catching the ball. So as you notice, we're good. And if I can do that for 10 seconds, I'm a winner. So the game spells winner. And if the ball falls all the way to the bottom without me catching it, you'll see that lose message. So I'm going to try to win one more time. There we go. I'm moving my platform to catch the ball. All right, and I won. So we can make it a lot more difficult by tweaking the time that you have to continuously catch the ball in code. We'll see that when we delve into the code. But essentially, we're able to use the thumb joystick to move that platform around in our game to catch our ball. So we'll take a look at the specifics of how we can tweak those settings in code and how this all works together. But this is a really cool game, and you can change the difficulty level to make it even more fun and exciting. There we go, I won again. Like some of the other games that we have developed, this one is also highly addictive. Okay, let's take a look at the code for our Joystick LED matrix game. There are a few modifications to what we've seen before. Remember, we're continuously building on our previous projects. The first major change is, in addition to the libraries we had included before, we're now going to include a stopwatch third-party library, and that helps us to keep time. Let me show you the documentation for that library. So this is the link to the library. It's out on GitHub. I will post the link in the resources for the project. But again, when you come out here, you just download the library and you'll save it to your libraries folder in your sketchbook location. So next, continuing with the code review, we've seen this before where we have our slave select pin set up to 10. We externalize the number of horizontal and vertical displays into variables. Previously we just had 1, but I put that out there to make it a little more self-documenting. We create our matrix object, which is a max72xx panel object. Then continuing on, we have a couple of other variables. Just the length is, the x and y coordinates, they go up to 8. And we use a couple of pointers, which we'll talk about those a little later on. For the joystick, we have to keep track of what the current position of the joystick is and what the falling position of the actual ball is. So we have some variables that do that. And of course, this pertains to the joystick, the vertical, horizontal, and select readings. So we set those up, those pins there. For vertical, it's pin 0, A0, I should say. For the horizontal is A1, and the select is A2. Next, we set up the stopwatch object. So this was from our stopwatch library. What we're specifying here is we're initializing the stopwatch, and we're saying that we want the timing to occur in seconds. So there are a couple of different options that you can use, and you can look at the documentation for that library, but we're using seconds. The next variable is time to win, and we've set that as 10 seconds. Here's where you can increase the difficulty level. So if you want to have someone continuously catch the ball for 20 seconds or a minute, you can change that accordingly to increase the difficulty level of the game. In our setup, there's some code we've seen before. This section might be new. It's just resetting variables that we'll be using further on. And next for the joystick, we've seen this setup before where we enable the input pull-up resistor. And then we start our game. All start game does is it resets our clock and starts the clock again. So that's to initialize the clock from our stopwatch library. Okay, let's look at the loop. Loop is very simple. We have a function called play game. I'll dive into that. But essentially, throughout the loop process, remember this executes over and over. If the time that has elapsed is greater than the time to win, meaning that 10 seconds or whatever you set up initially for the time to win, then we call the winner function. And winner simply displays that scrolling message win on the screen. So I'll go down here to winner. It would just draw that text win, and it starts the game over. So as far as the displaying of the scrolling text and displaying of text on the screen, there are a few functions that we can use that leverage the max panel library, and here they are. You simply pass a string into it, and it takes care of drawing the text on the LED matrix. To draw the scrolling text, you can use this function. You simply pass the text in and it's going to scroll that text across the screen. So two handy convenience functions for you there. So let's delve into play game. This is where all the magic happens from our loop function. So let's look at the play game function. What we're essentially doing here is we are generating a random number of the y-axis where we're starting. So that's where the ball initially starts from, and we continue decrementing, going down and drawing the pixel as the ball falls. So that's where the loop function comes into play, where we're drawing that pixel. It's in one spot, then next it drops to the spot below, and so on and so on. During that time, remember the joystick could be moving, so we call this set joystick position in order to draw where that platform is. So I'll take a look at that shortly. But then next we continue drawing our pixels, and we determine if a collision has occurred. So when the collision has occurred, that means the platform has caught the ball. Also at the bottom, if we continue going on, if I is equal to 7, that means you've reached all the way to the bottom. The ball has reached all the way, or the current lit LED pixel has reached to the bottom of the screen without a collision occurring, meaning you didn't catch it with the platform. The game is over. So we call the game over function. So let's quickly look at the set joystick position function. Essentially, we are doing a reading like we have seen previously of the vertical horizontal positions. We're performing a map to draw that on the screen. And remember, for the joystick, our platform is 3 sort of pixels or LEDs wide. So we have to add on to either side. That's where down in this draw pixels, that's where down in this area we draw the pixels and we increment and decrement the current position, so we can make our platform 3 pixels wide. And we also have to keep track of that platform, or keep track of the current position of the platform. So that's why we set those global variables. All right, so the game over function is pretty straightforward as well. We just, draw that text loose to the screen and we start the game over. Finally, the main function, which is the collision occurred. Basically what this is checking for if the current position of your platform is, at or below the position of the ball or the current LED that's lit, then it returns true. And if collision occurred as true, we continue on with our game. If collision occurred as false, when it reaches all to the bottom, game is over. So there's quite a lot of code in this particular program. Hopefully I've broken it out for you to be modular so you can understand what the different functions do. But I would encourage you to take some time and look through this code to become familiar with how it works, and you can also tweak it to change the game accordingly as you see fit. To summarize, in this project, you learned how to use a joystick in your circuits and how to take readings that can be used to control the position of components in your projects. You were also introduced to the max7219.matrix module, which can be used in conjunction with third-party libraries to control your 8x8 LED matrix. You now have the knowledge to include these two components in your circuits. Let's move on to our next project.